Good morning to one and all. Myself Amit Sharma, working as an associate professor in IAS IPS Academy, Indore. So, in our series of lectures, this is the part 3. In the previous lectures, what you have learned is what is earthquake inside the earth, convection current, plate tectonic theory, plastic rebound theory, focus in epicenter, seismograph records, basic terminology related to earthquake, magnitude, intensity, difference between magnitude and intensity, and isoseismometrics. Now, in this lecture, we'll study the seismic zones in India, inertia forces in structures, effect of deformation in structures, horizontal and vertical shaking, and flow of inertia forces to foundation. So, seismic zones in India. India lies at the northwestern end of the Indo-Australian plate. The major tectonic subregions of India are the mighty Himalayas along the north, the plains of Ganges and other rivers, and the peninsula. So, if we see the seismic zone in India, which are given by as per IS 1893/2002, the blue one is zone 2, yellow one is zone 3, the area with dark yellow is zone 4, and with brick red is zone 5. So, the most recent version, this is basically the most recent version of the seismic zoning mapping of India, assigns level of seismic activity for India in terms of zone factors. Zone 5 is highly prone and zone 2 is the least. So if we talk about the location of zones, the most vulnerable is zone 5, where in the past some powerful shocks have been occurred. Earthquake with magnitude 7 have occurred and have the potential of more than 9. This zone is included by northeastern India, Andaman Nicobar Island, some parts of northwestern Bihar, eastern parts of Uttaranchal, Kangra Valley in Himachal Pradesh, Srinagar area in Jammu Kashmir, and Rann of Kutch in Gujarat. Some of India lies in zone 3, where the maximum magnitude of 7 can be expected. New Delhi, Mumbai and Calcutta lies in zone 4, and only Chennai lies in zone 2 among the metros. Since zone 2 and zone 1 lies or their situations are far from Himalayan plate region, fewer or rarely earthquake strikes in these regions. These are some of the major earthquakes that have occurred in India right from 1819 till 2001. So now, let us talk about inertia forces in structures. Earthquake causes shaking of ground, so a building resting on it will experience motion at its base. From Newton's first law of motion, even though the base of the building moves with the ground, the roof has a tendency to stay in its original position. But since the wall and the column are connected to it, they drag the roof along with them. This is much like a situation that you have faced with when the bus you are standing is run with stars. Your feet moves with the bus, but your upper body tends to stay back, making you fall backward. This tendency to remain in previous position is called inertia.